Alrighty, so before we actually start the reading guidance, there's no vocab, by the way, for this section. Before we start the reading guidance, I want to clarify something. You're going to see maybe what looks like a strange notation. X plus 3, right, to the 1/2 power, the whole thing to the 1/2 power. What that really means is the square root of x plus 3. The whole, whatever's inside there that gets the 1/2 power is technically the square root of that. Please know that. If I put it to 1/3, it'd be the cube root, right? That sort of thing. But I think the only ones I'm going to actually throw at you have the 1/2 in them. Alrighty, so solving a square root equation. Well, we want to know what this thing equals, right? 3 plus the square root of, and then the quantity 2x minus 3. As we've discussed, you need to clean up the outside first. Right, so here you're going to subtract that 3 from both sides. Clean up that outside. That leaves us with 2x minus 3 equals 5. And as we talked about, square both sides to clean it up here. So in this time, squaring both sides, you're not actually going to FOIL it, obviously. You're just squaring the square root, wipes out the square root idea. And this side, squaring 5 is 25. Then we can go ahead and deal with what we see left. So add the 3 to both sides, divide it to 2, and x is 14. And as we've discussed, you do need to check your answers for extraneous solutions. So check every answer that you get and plug it back into the original equation, not into some version down here. So you plug the 14 back in, and we do see indeed that it is true. 28 minus 3 is 25, square root of 25 is 5, 3 plus 5 is 8, so it does work. Alrighty, similar story here. We're going to take this one and solve. As we've mentioned before, we need to clean it up first. So add that 5 to both sides. That gives us the square root of 4x plus 1 equals a positive 5. And then we're going to go ahead and square both sides. So I got 4x plus 1. Whoops, there we go. The square root of that squared equals 5 squared. And so that gives us 4x plus 1 equals 25. Subtract our 1, 4x equals 24. Divide the 4, x equals 6. Now again, you'll want to check that. So we're going to plug that back into the original equation. 4 times 6 plus 1, you need a little bit of room here, there we go, minus the 5. Well, that's 24 plus 1 on the inside, minus 5. So 25, square root of that, minus 5, and that's 5 minus 5, which is indeed 0 up here. So it did work. There you go. Alrighty, so now back to the idea of checking for extraneous solutions. So right here again, start by adding that 5 off to both sides, so we get x plus 5 over here. Okay, so I'll give you a second to kind of follow along here. Subtract that, add that 5 off. Now then, in order to get rid of the square root, we square both sides. So x plus 7, square the whole thing. X plus 5, square the whole thing. This side you're going to FOIL over here. You obviously don't have to because we're just deleting the square root. So x plus 7 equals x squared plus 10x plus 25. All that equals 0. When again we move the x over, so subtract the x, subtract the 7, move them over here, gives us x squared plus 9x plus 18. I'm going to factor this, obviously. That's why we spent so much time doing that, right? So we get x plus 3 equals 0, x plus 6 equals 0, which means negative 3 and negative 6. But again, we have to check for an extraneous solution. Plug them both in to the original equation. Plug in your 3. And we're going to find, obviously, if you follow it down, it does work. Plug in your 6, though, and we find out it does not work. On the left side, we end up with positive 1. On the right side, that negative 6. Or, I'm sorry. On the left side, we end up with positive 1 minus 5, which is negative 4. The right side ended up with negative 6. That's not a true statement, so that negative 6 was an extraneous solution. As we know, that does happen to us. Okay, so then, again, our quest to solve here, finishing these up, one of the things we need to make sure and remember is to check for those extraneous solutions. And you'll see that happen in this problem. So, to start out with, we have that 5, square root of their 5x minus 1, and plus 3 on the outside, equals x. And we do know that we need to clean up the outside around the square root before we can do anything. So the square root of 5x minus 1, we're going to go ahead and obviously subtract that 3 from both sides. So on the right side, we get x minus 3. Again, just a square on the left, so we can square both sides. Like so. And once we do that, on the left side, obviously, that yields us just 5x minus 1. I don't know if I could write that straighter. 5x minus 1. And on the right side, x minus 3 times x minus 3. You all know how to FOIL that. So we end up with x squared minus 6x plus 9. Now we're shooting for that 0, right? So we can go ahead and factor it out. So subtracting 5x from both sides, adding 1 to both sides, yields 0 equals x squared minus 11x plus 10. And then I go ahead and I factor it. And I'm going to get, a good thing we already learned how to do this, huh? X minus 10 and x minus 1. So it looks like we have two very good solutions, right? But again, we need to check those back in the original equation to make sure that they work. So I have the square root of 5 times 10 minus 1 plus 3. And so that's a square root of 49 plus 3, or 7 plus 3, which does indeed equal our 10. So that one works. Oh, I forgot to write the solutions, I guess, right? X equals 10 and x equals 1 were our two supposed. Plug in the other one, though, and we have the square root of 5 times 1 minus 1, and then again plus 3 on the outside. So that's the square root of 4 plus 3, which is 2 plus 3, which is 5, which does not equal the 1 that we should have had on the x, for the x on the other side the whole time, right? So that means that the x is 1 is not a solution. It's extraneous, and x equals 10 is our solution. Part B of that, when should you check for extraneous solutions? So the idea here, and we've discussed this in class hopefully by now, is when you raise each side of an equation to a power. Anytime that happens, strange things like these extraneous solutions tend to show up, and so we need to be looking out for that. All right, so now it starts getting really fun, and we're going to really put your algebra test or algebra skills to the test. So when I have two radicals involved, what is the solution of the square root of the quantity of 2x plus 1 minus the square root of x equals 1? So just like you might think, we're going to put one radical on each side. So here we're adding the square root of x to both sides. So we get the square root of the quantity 2x plus 1 equals square root of x and then plus 1. Just like you might think, we're going to square both sides. When I do that, obviously over here on the left, I get 2x plus 1. On the right, FOIL this out. It doesn't just become x. It doesn't become x plus 1. You need to FOIL it out. Square root of x times the square root of x is x. And then 1 times the square root of x plus 1 times the square root of x is 2 square roots of x. And 1 times 1 is 1. Now then, so again, FOIL that out. If you're not sure, pause it. Even come ask me. I'll FOIL it with you all you want. But we did practice ones like that in previous unit. So here then, we're going to go ahead and try to clean this thing up, right? We're going to subtract this x from both sides, this x here, and then we're going to go ahead and we're going to subtract the 1 from both sides, leaving us with just x equals 2 square roots of x. Now then, we can square to clean that up. I know this is getting kind of convoluted here. We can square to clean that up. So square this side, x squared, square this side. Again, becomes 4 times the square root of x squared, which is just x. So x squared equals 4. Now it's looking a little bit nicer. Subtract that 4x from both sides, we get x squared minus 4x equals 0. We know how to factor this kind. We've practiced this before. X and x minus 4, so x equals 0 and x equals 4. You do still need to check for extraneous solutions. So plugging that 0 into both x's here. That's what I mean by that. Plugging that 1 in, or 4 rather, into both x's and proving that yes, indeed, both solutions work. So 0 and 4 do work. This one's going to take some practice, and we most certainly will, and we'll work every single one of them you want in class. Not a problem. Okay, so I'm going to warn you at the outset, this is a long problem. And I will happily, if you need this one gone over again in class, or any of them from this section, do not hesitate to ask. Do not assume, oh, I'm the only person asking. Don't do that. Please make sure you ask for help if you need it. Remember, this is an Algebra 2 concept. So, okay, and I'll warn you too, we're going to have an extraneous solution, so just hang out for the long haul. So we're going to start out. I'm going to write it by hand here. So I'm going to have the square root of 5x plus 4 minus the square root of x equals 4. Now, before we go any farther, I want to move this radical on the right side, or on the left side, over to the right side. So again, we're adding that square root of x to both sides. So I have the square root of 5x plus 4 equals the square root of x plus 4. Obviously, we're going to have to go back and square both sides at this point. It's going to require using your foiling skills. And so on the left side, that just clears up the square root for us. So 5x plus 4 equals, on the left, we're going to FOIL. Now I'm going to skip showing the work on the foiling here. You should be able to do this. It's going to yield x plus 8 square roots of x plus 16. If you're not sure on that, pause it. Go ahead and prove it. Do it yourself. No problem with that. Okay, so now you might ask yourself, okay, I got to move stuff around. Great. Last problem you did, you moved stuff around. You got rid of the numbers in it and made it easier. Just the numbers by themselves, the constants. Not going to happen this time. But what we're heading for is to be able to get rid of the square root that's left right here. And in order to do that, I'm going to need to square it. So I'm going to leave it as the only thing on the right side. So let's go ahead and we're going to subtract this 16 from both sides. And we're also going to subtract this x here from both sides. That will leave me with 4x minus 12 equals 8 square roots of x. And I'll pick that up here in just a second. I'm going to clean this up. Okay, so again, I promised this was long, so I moved it up here for us. So next up, we're going to square both sides. And again, the reason that we moved all the stuff that doesn't have a square root to the left and the stuff with the square roots to the right, so that when I square the stuff on the right, it will kill the square root. Now, if I didn't do that, I would have ended up foiling and throwing another square root in the middle again. So, square this side, square this side. On the left, again, I'm assuming we can FOIL here. That's going to yield 16x squared minus 96x plus 144. On the right side, it's going to yield just 64x. Now, obviously, I want to get 0 on the right side, so subtract that 64x from both sides. So I end up with 16x squared minus 160x plus 144 equals 0. And it's important you didn't mess up this part right here. Now you're thinking, oh, great, I have to factor that. Not exactly. I happen to have noticed, and hopefully you did too, that there is a 16 in common among all three of these. So I'm going to factor that out before I go any farther. So that gives us 16 times x squared minus 10x plus 9 equals 0. And once you divide off that 16, because 0 divided by 16 is 0, I am left with just the inside, x squared minus 10x plus 9. Okay, so time to factor that. And that one should be pretty easy for us. X minus 1, x minus 9. So, obviously, I got that equals 0, right? So x equals 1 and x equals 9. But we need to check for extraneous solutions. So we're going to plug that back into the original equation, both of them, and we're going to find out which one's extraneous. And obviously, you can see right now the answer key there, the 1 is extraneous. So hold on, we'll do that again, or do that. All right, save a little bit of time for you here. I went ahead and plugged in the 1 everywhere we're seeing X, and you can follow it down here. It does not work. We tried to prove that 2 equals 4, not true. Take a second, need to look at that. So again, proving that 1 is an extraneous solution. And here we are proving that 9 is indeed a solution, plugging it in everywhere we see that X. And again, you can follow it down, proving that 4 does indeed equal 4. Therefore, 9 is a solution. Kind of a long one, I know. But again, we'll work these, discuss them until it snaps with you. So, all right, a little bit of homework over this is 2 days on this topic to make sure that we've got it down.